So hi everybody, thank you again for joining us. So today we have Jarek or Jarek Wichert, I guess I hope I said that reasonably okay, who is going to be talking about green IT. Jarek has an IT asset management background, but his presentation today is very relevant for anyone in IT who needs to understand about green IT, which is pretty much all of us really. Before we kick off, I would just like to remind everybody that our next event is on the 20th of February. It's an in-person event in our offices in the City of London, and our presenter will be Ronan O'Carroll from Syniega, and he's going to be talking about a software asset manager's guide to cloud migration. So having said that, we'll kick off. So Jarek has a very big IT asset management governance background, has 20 years of experience, and has also contributed to various international standards organization, ITAM standards papers and things like that. So, and he's been working in his organization, Schneider Electric, for the last, you said it was 3 to 7 years really, with the green IT, sort of with the green IT stuff, so to speak. So welcome, Jarek, and if you can kick off. One other thing, actually, Jarek has said, could we please hold off on question? We'll have a question and answer session on the end, rather than having questions through the presentation. However, if you do have a question, something occurs to you during the presentation, please put your question into chat, and then at the end of the presentation, we'll ask the questions and get Jarek's answer. So please put your questions in chat, and we'll have a Q&A session at the end. So thanks very much, and thank you, Jarek.
Thank you very much, Kali. Hello, everybody. My name is Jarek Wichert, as Kali said. She made pretty well an introduction to myself. I have over 20 years experience in IT asset management. However, what is most important, for over last 9 years, I was involved in sustainability. And somebody who is looking at my experience will say why somebody who is working in IT asset management was involved in the sustainability. The answer is very easy. It's because of the company I'm working with. 10 years ago, I joined Schneider. In Schneider, we aspire to be the digital partners for sustainability and efficiency for our customers. And to do that, we need to lead ESG by example in our ecosystem. This has been confirmed by several recognition. You can see several examples on the screens. But on the other side, also, we are encouraged within Schneider to work on sustainability and to look on sustainability in our corner of our activities. Now, I am also part of our IT Asset Management Forum, a non-profit organization which promote the business practices of ITM. I am trustee, part of the board of trustees for the IT Asset Management Forum. We are having over 1,000 members from 42 nationalities. It's a very international organization. There are several special interest groups. If you are interested in IT asset management, I strongly recommend you to join it. Now, having said it, I would like to come over to our the reason of this presentation. If you just allow me one moment, because I would like to correct one point. Okay, and then I will just share my screen. I apologize for the small technical issue. No, you should be able to see it. So what we will go through, I will give you a short overview of our digital world, what implication it is having on digital carbon footprint, explain the paradox which we see between IT and sustainability, explain also the greenhouse gas emissions from IT perspective, what is the provision for the energy demand of digital technology, how it is translated on IT within business IT or enterprise IT, and then give a short overview about the 5 pillars, which 5 areas, key areas, which should be tackled if you want to improve, enhance the IT sustainability in the company. Now, to begin with, digital world, if we simplify it, maybe not oversimplify, but simplify it, digital world, digital technology are extended over the last year a lot, and are practically in every corner of our life. But if you simplify it, you can divide it with that between four main pillars. The first one is naturally the consumer. On the consumer side, we are consuming a lot of information, and many of them through digital technology. The second is naturally the business, so enterprise IT. There is also digital technology deployed very strongly on science, for example, for meteorology, for weather prediction, for climate change modeling, healthcare, for example, the early illness prediction, or even for criminality prevention. Another area where digital technology has huge expansion over the last years is in industry. That's what we call digital industry or industry 4.0. And here we are having, again, four main subsets of industry. We're having smart cities, we're having smart factories, we're having also smart buildings and smart logistic, including also the logistic of liquids, so gas and oil. Having said it, I don't know, it's not always to know that the four different areas having different usage of internet traffic. The consumer is the king. It's consuming right now up to 75% of internet traffic. Just behind the, just before the enterprise IT, with around 20% of the traffic is due to business IT, and only around 5% right now due to the internet traffic generated by digital industry. However, the last area is the one of the most interesting, because the last area is having very strong decarbonization potential. What it means is that it's not only that is something what is increasing efficiency of manufacturing, efficiency of management of our cities, of our building, but also is saving energy, is allowing to reduce emission of the industry. There are studies which are stating that every kilo of CO2 emitted by digital technology deployed to industry is having the capacity to decarbonize 7 times more. So practically for 1 kilo, you can save up to 7 kilo of CO2 normally emitted by the industry, if it is properly deployed. Now, due to the massive extension and adoption of digital technology, there are also a lot of myths and legends, which very often are mixed up with facts. I would like also to speak a bit about that, because sometimes they are creating a lot of confusion. So my idea was to make a quiz. I know we are not always having the technical mean, but I will go step by step, giving you 3 questions, and you can answer in the chat. What do you think, if it's true or false? Firstly, there was a publication done by Shift Project, by New York Post, Yahoo, and The Guardian, Thomson Reuters, and other newspapers several years ago, saying that streaming 30 minutes generates the same carbon emission as driving 4 miles. How do you think? Is that true or false?
People could put their thoughts in the chat. Oh, so we've had a few people say it's true, and in fact, one person saying false. It's actually more than the same carbon emissions as driving 4 miles.
Good.
And then a couple of people are saying false.
Yeah, this example is an example of one of the myths or legends. Actually, it's not true, it's just a legend. Why? Because there was a study conducted by International Energy Agency, which stated that carbon footprint of 30-minute video streaming is up to 50 times lower than that what is stated here. So it implicates that practically that streaming for 30 minutes generates so much carbon footprint as driving 100 meters, not 4 miles. Okay, so it's still, it's generating carbon footprint, it's generating emission, but it's not as big as it looks like. On the other side, there is the other example. There was a publication done again by known publishers stating that cryptocurrency, in particular Bitcoin emission alone, could push global warming above 2 degrees. What do you think? Is that true or false?
Most people are definitely saying they think it's true.
It is true that Bitcoin emission or cryptocurrency mining is the very it's consuming a lot of energy and it's generating emission, especially taking into account that globally the energy generation is currently, I think, in the global mix is relying only in 30% or 38% on renewable energy. The rest it's gas or coal. So definitely there are some emissions. However, again, the International Energy Agency made a study on it and stated that it is polluting, it is generating emission, but not so much. It's actually responsible for between 10 and 20 million of tons of CO2, which is around 0.3% of the global energy emission. And it's not sufficient to cause the global warming pushing above 2 degrees. So saying that, let's go to the third one. I will not ask this question, I will state it, and this is another example of a myth. And there was a song in past, maybe several of you can still recognize it, can still remember it. It was a hit, and as a hit, it surpassed over 5 billion YouTube views and downloads. So there was also a statement done by some media, by some publishers, that it is consuming as much electricity, it caused the same consumption of electricity as consumption of several African countries over a single year. Again, this has been checked and it was not true. It was actually in the consumption of the downloading of the song, the 5 billion times. The song was estimated around 200 less than that what is stated here. And the last example is from artificial intelligence. It is a very fashion topic right now. It is stated as the second cause of emission in digital technology after cryptocurrency mining. So there is also a publication stating that training one natural language processing model is equivalent to around 300 round-trip flights between New York and San Francisco. And this is an example where nobody knows. Simply saying this is right now not checked, it's uncertain. However, looking on artificial intelligence and the natural language processing, there are a lot of factors which are impacting let's say the energy intensity which is needed to program it. And on the other side, also it can be used for several areas. And this is my second point of that. It's not about how polluting is this activity, but what is that for? It's something different if you use artificial intelligence for leisure, something different to save life by predicting illnesses in early stage, or by helping our governments to keep the criminality low. So it's always relative, and the usage and emission should be always put in the context what it is for, and if it is justificable or not. Now, having said it, we move over to next point, which is speaking about digital carbon footprint. There is a lot of in the media speaking about what are the emissions, what is causing the emission, but actually how do we measure it and how it is impacting our part. And there was a study evaluation done by International Telecommunication Union. International Telecommunication Union, I don't know if you are aware, is one of the oldest United Nations agency. And they make a study in 2050, estimated that at the time, the energy consumption of ICT, of digital technology was on the level of around 969 terawatt hours, which represented around 3.9% of total electricity. What take into account the energetical mix was translated in around 740 megatons of CO2, which was equivalent to around 3% of the global CO2 emission. And this factor, 3% of global CO2 emission, has been taken as a baseline for GHG protocol, greenhouse gas protocol for ICT sector. So right now, any emissions which we are right now emitting through digital technology, if we are looking on science-based target, if you are looking on greenhouse gas protocol, it's always reflected on the baseline done by this study. The study was found afterwards criticized, was found that it's not correct, that there were assumptions taken, or there was another study performed which was saying that the actual emission in 2015 was not 740 million tons, but a bit more, or it was the energy consumption was up to 50% more than stated. Still, this is the baseline taken GHG protocol, and this is taken as a baseline for the science-based targets, which are targeted by greenhouse gas protocol. The current state in 2020, we are the ICT electricity demand reached almost 1,935 terawatt hours, which was equivalent to around 2.5% of global CO2 emission. Again, you can find different studies. Some of them will say it will be 2.5, 2.9, on average around 2.8. Why it is always so inexact? Because each study is taking different assumption. Not every study is taking all digital technology. Some of them are focusing only on IT. Some of us also are taking, for example, our consumer market, other only professional, and so on and so on. Now, what is interesting, in 2020, there was a study performed by Schneider Electric Research Institute. There was identified the main factors which were driving the electricity demand, the growth of the electricity demand. On one side, it's again expansion. The number of ICT users is growing. And the second are social networks and streaming. We are using a lot of social networks, and this is also, again, increasing the demand of electricity. And three, the new ICT trends. They are again behind, they are also driving the growth of electricity demand by of digital technology. Here we speak mainly about big data and artificial intelligence, the Internet of Things, blockchain, and if you speak about blockchain, you speak also about cryptocurrencies. Now, having said it, how it looks from the sustainability perspective. So, as I said, as a baseline for energy demand has been taken the ITU, so International Telecommunication Union study. It was assuming 3.9% of global energy demand in 2015, which was at the time equivalent to around 3% of CO2 emission, global CO2 emissions. Now in 2020, maybe before that, other study was stating that it was not 3.9% of the electrical energy demand, global electrical energy demand, but it was around 7%. What looks that it's correct, what is not far from true, because in 2020, the global electricity demand by digital technology has been estimated for around 8%, and the prediction for 2030 is around 10%. Somebody said it's not so big over 15 years to go from 7 to 10%. There is a growth, but if you are looking also how the digital technology has expanded in our day-to-day life, also on the consumer side, it's not so big. The trump is let's say the trick is in the absolute value. As the global energy demand has increased, the percentage increase is implicating huge absolute value. So practically the 10%, so 2%, 3% increase from 2015 to 2030, it implicates 1,395 terawatt hours. To give you an example, and this assuming in 2015, the energy consumption of ICT was on the level of 1,700 terawatt hours. So again, it was quite high increase. So the message is what we are facing is extension of ICT. Digital technology are applicable in more and more areas. They are used more and more frequently, and it is creating an increasing energy demand. On the other side, from the energy emission, we see decrease. There was assumption done by ITU in 2015 that if ICT sector wants to keep on the 1.5 degree science-based target trajectory, it requires that by 2030, the emission caused by ICT sector will be decreased by 50% versus the 2015 baseline. And this has been stated directly in the publication of ITU, which is cited here, L1417. Now, what we see in reality, we see that yes, the emission of digital technology are decreasing from 3.1% in 2015 to 2.8% in 2020 and 2.6% in 2030. However, the absolute value, if you compare it with the ambition of ITU, are really very low. We are still not there. I mean, again, the global emission has increased. So it's true that the portion, proportionally in percentage, we are decreasing the emissions slowly, but we are decreasing. But the absolute volumes, the absolute values which need to be decreased are still much below the target. So this is the paradox of digital sustainability. How to achieve, to make the reduction by 2030 by 50%, to reduce almost half gigaton CO2 by 2030 versus baseline from 2015, but at the same time be able to satisfy the increasing demand for ICT technology, which is translated in increasing energy demand. So, what is driving the increasing energy demand? This is another overview of a study performed by Schneider Electric Research Institute, which analyzed the drivers for energy demand for ICT. The biggest energy demand right now is due to the ICT device manufacturing. This is what we will see afterwards as the embedded demand. The second is the the growing demand for fixed and mobile network. We see that also that the coverage of mobile network is growing. We're having new generation, new densities, and also the capacity of our fixed networks is also growing. So this is the results of it. The third factor behind the increasing electrical demand are increasing of DC infra data centers. The fourth, in past, it used to be IT device use, but you see that exactly at this time, we see that the demand for IT devices will decrease. So the energy demand due to the IT device use will also decrease, but will be taken over by usage of network equipment. Another upcoming star in terms of demand of electrical energy from ICT sector is IoT. It started several years ago. It popped up already in 2020. We see the increase, but there is expected to be even higher deployment of IoT in the coming years. And the energy demand due to IoT device usage will overcome ever the energy demand due to network equipment usage. The last but not the least is the storage. So that are the main factors, and this is something that is important to take into account if we are looking how we want to reduce carbon emission, because carbon emission almost always somewhere are related with demand for electrical energy. Now, what it means, greenhouse gas emissions. You probably already know it, but just to set the common baseline, the greenhouse gas emissions are divided in 3 different scopes. The scope 1, which is mainly due to company facilities and to company fleet. The scope 2, which is mainly due to electrical usage, heating and cooling for one own use. So it's, let's say, that what is used directly by the given scope, by the given company. And the scope 3, which is divided in the upstream and scope 3 downstream activity. The upstream is that what we are purchasing in our company or in our household, what we are taking from our vendors, and what CO2 emission it implicated to manufacture and to provide, to deliver the goods to us or the services to us. The downstream activities is that what we as a company, as a service provider, were providing to our customers and what costed us in terms of CO2 emission to provide the services or goods to our customers. If you look at the ICT sector, GHG emissions are mainly within the scope 2 and scope 3. Why it is important is because also of that how we are analyzing the digital carbon footprint or carbon footprint of any products or services is always linked with the life cycle, with product life cycle of the service or of the product or the service life cycle, which is analyzed. In terms of IT devices, is not different. We are having here the first stage, which is the manufacturing logistics. During the manufacturing, extraction of the materials, production and distribution, there are generated emissions of CO2. This stage we called the embodied carbon footprint in the IT products. It is called on the market, on the global supply chain, as the cradle to gate stage. Then if we are going in the usage, that's what we are seeing as consumers or as IT departments in companies. That's what we are using in terms of IT. What we are acquiring, what we are deploying, what we are using, and afterwards what we are retiring. This part, it's called the usage stage. The usage stage can be always extended by, if we are retiring IT equipment, we can refurbish it, we had renew it and offer a second life to it if we are selling this on the secondary market. So this is the usage state, and the emission called to it, we normally called the usage-based CO2 emissions. The third stage is the disposal of IT devices. Here again, what is taken into account is, if we're applying circular economy, is what is reused, which part has been reused. There need to be also some energy used, so therefore also emissions to extract the parts and reuse them, to recycle the raw materials, and again to avoid go to the landfill. The more we are going to the landfill, the more emissions we are causing too. This stage between for the disposal of IT assets, it's again called it's again counted as embodied carbon footprint. The usage plus embodied, it's called the gate to grave. Just to give again the a bit of baseline how carbon footprint of IT solution, IT products is analyzed. Now, looking at it from enterprise IT perspective, if we're looking on typical IT, on typical company, we're having users and users which are having devices. Those devices are having carbon footprint. Those devices need to have some infrastructure, some servers to connect it, and which are running on-prem application. The on-prem application can be run on the devices or can have the client server, the traditional client server architecture. The application itself are also needed some processing power, also generating some emissions. They need to be network which are creating the interconnectivity, which is also requiring some energy, and therefore also there is some CO2 emissions. Now, we spoke about the IoT expansion and the explosion of deploying digital technologies to industry. This is another area which needs to be taken into account in normal company. If we are looking afterwards on the trend to go to cloud, there is again another elements which are coming to the cloud. We need to have connectivity, so again fixed or mobile network to be able to connect to cloud solutions, and we are having cloud solutions which are deployed normally in big data centers and which are requiring processing power, and therefore also are creating greenhouse gas emissions. Now, how it looks that from the division between usage CO2 emission and embodied CO2 emissions. If we are looking on end user devices, normally up to 70% of the overall carbon footprint of end user devices is due to the manufacturing and disposal. Only 30% due to usage. To give an example, an average laptop nowadays is having the carbon footprint of average laptop is estimated of around 400 kilos of CO2. For IT infra, the carbon footprint embodied in the server in the devices is representing around 20% of the overall carbon footprint. 80% is coming from usage. Why? Because the infrastructure is normally heavy used and it's used normally 24/7. If we are looking for IoT, it's the same approach. It's around 20% due to embodied carbon footprint due to manufacturing and 80% due to usage. For network, it's even more, 90% due to usage. And then we are having the cloud. Now, so what are the main areas which would allow us to tackle the sustainable IT? You can reduce carbon footprint, you can decarbonize your IT normally using 4 levers. Either using CO2 offset, so you are buying some carbon credits, you are paying for it, sponsoring some sustainable projects which are capturing CO2, for example, planting trees. So this is easy and fast way to decarbonize if you have budget for it. But again, it is not something what normally it's recommended to do on the long term. Second part, which can be used, is to use renewable energy. We say that every application requires some processing power, and therefore also is increasing energy consumption. If the energy is green, then practically we are not generating, we are reducing the emission of the CO2 just to the embodied part.
Sorry, Jarek, do you have points that should be appearing on the screen?
It will be in 2 seconds.
Okay, no worries.
Yeah. Don't worry. The fourth area is low carbon design, by design. So to make sure that what we are deploying is done by design. And here where you will see the points showed on the screen. So the 5 key areas, if you want to start to enhance, to reduce the carbon footprint of your IT, is to what I am calling stop the bleeding. The bleeding is normally by deploying new things. To make sure that what is new deployed to your company, to your household, is not making the situation worse. And this is starting with looking what we are buying. Do we know what is the carbon footprint of the new mobile phone we are buying? Do we know if the mobile phone we are buying compared with any other device from the competition is above or below in terms of carbon emissions. How do we design our solutions? Do we measure, do we make sure that there are minimum elements of servers, of clients which are accessing it? So we are reducing the overall carbon footprint of the solution. This is very important. Do we make sure that our IT vendors, they have a climate pledge and they are doing something for sustainability? Is that a differentiator in our procurement? This is something where, again, with very low effort, just by looking at, you can have different decision and you can afterwards estimate if it is worth, if there is the cost difference or not, but at least you know where are you going and that sustainability is part of the procurement criteria. Second part for the purchasing is also procurement of the green energy, so-called PPA. This is also something what is entering here. Another area where you should look at it is the green, the green design and architecture. Again, how our IT solution in our companies are designed, or in our household. Do we have something with a lot of sensors, or we try to combine it? We are making some hybrid solutions. Do we have modular design? Is that what we are buying, something what have a modular structure which can be repaired? Are we monitoring our usage of resources, so we minimize the resources used? Are we developing our software, making sure that only the functionality which are active are still using processing powers and the other are switched off? Are we making sure that our code is reduced? Why it is important? Why it is important to save energy? It's because what I said at the beginning, we see the paradox of sustainability. We have increasing demand of digital technology and urgent need to reduce the carbon footprint. Decreasing the demand on energy through our actions will allow also to reduce the carbon footprint. We need to support it. Additionally, you should know that right now around only 38% of global energy mix is renewable. So it means there is not sufficient currently renewable energy for everybody. If we are able to reduce consumption of our household, of our company, we are able to make sure that others can use renewable energy. Now, third area, operationalized circular economy. What does it mean? It means that we are embedding circular economy principle. So redeploy, reuse, recycle, and strive to zero landfill. We operationalize this in our lives, in our private lives, in our business life, and also in our IT life. In IT, from IT asset management, how we are embedding this in our operational processes like onboarding, offboarding, asset refresh, release of new solution, or the commissioning, and afterwards asset disposition. Do we have embedded green principles in our IT asset management policy or in our IT policy generally? Do we have guidelines for our users? What are the good green habits? Do we redeploy the devices for employees and newcomers, or we are just buying new one? Do we think if it is possible to extend the life cycle of the devices and solution just by upgrading it instead of swapping them? Do we offer our employees buyout opportunity to offer second life to the devices? Do we use authorized IT asset dispositions vendors to make sure that what is retired from our environment afterwards is properly disposed according to the circular economy principle. So again, redeploy, so refurbish, reuse, recycle, and reduce to the minimum, preferable to zero, that what is going to landfill. The third one, usage of renewable energy. Again, are our sites, our households, do we see what is the energy mix of our energy provider, and do we have any possibility to switch to others which are having better energy mix with higher participation of renewable energy? Another point is increase awareness on the green digital habits. Before I am going there, I wanted just to spot the green and blue part here. It is showing the impact of each of the points on the usage carbon footprint or on the embodied carbon footprint. So again, procurement is having impact on both on embodied and on the usage. You can, if you are purchasing, you are able to buy also more efficient devices and also see what is the total product carbon footprint of that what we are buying. The same for architecture, the same for the operation in circular economy. Using renewable energy is impacting only, in brackets only, the usage carbon footprint, but it's very important too. Now, why I'm putting as the fifth key area the increased awareness on the green digital habits. It's again, we say that there is the growing number of ICT users, professional on the business side, but also on the consumer side. So being able to give some guidance, increase the awareness of our professional users, we are also making sure that TOZO users are able to use TOZO principle also at home and in their environment. There are simple things on the user level, things like email. Do we make sure, do we inform the user that it's better to send emails with links instead of having file attached? Do they know that you are able to reduce up to 35% the carbon footprint of an email if you are using just links? Do they know that if they are making a web search, and they are able to reduce up to 30% of the carbon footprint of the search if they are not using search option itself, but they are using direct URL? Do they have information on the carbon footprint of the devices they are using? So they, for example, they can decide if they want to have one model or other in function of the carbon footprint, or if they want to stay a bit longer with the device they have. Do we provide them information about the carbon footprint of printers, printing? It's not only the carbon footprint of the paper itself, which is very important, but also the carbon footprint of the printers itself. Again, something done by one person, it's having very little impact. But if you have a company of 1,000, 5,000, 10,000, or 20,000 employees, summarizing it, it's giving a lot of impact. And the same on the private life. Now, to do that in the company, you need also to ensure that your management, your leadership is aware about the importance of the sustainable IT. And this is another pillar which is important to work to ensure the tone from the top, to ensure that the green principles are sponsored, are supported by the leadership, also in forms of directives embedded in the company policies, IT policies, especially IT asset management policy. Do we have in IT, in our company IT department, any KPI regarded to sustainability? Do we know what is, are we able to quantify it? how this is very important in terms of awareness to know what is our carbon footprint right now and where it is coming from. So again, for me, the awareness is probably the beginning, the most important. It's quoted here as the last, but it's the most important. Having data, having idea what you can do to decrease, it's the beginning of the patch. Afterwards, it's a question of structurizing and directing it. So with that, I wanted to finalize this presentation. As I said, this was for me a kind of introduction to digital carbon footprint. I hope you like it. And with that, I would like to come over to the question and answers.
Thank you very much, Jarek. That was really interesting. I very much enjoyed that. So please put your questions and comments in the chat, and we will relay them to Jarek to get his response. So we do have one question from Sushila. Are there any specific recommendations regarding what to consider to make architecture design patterns greener? Or do you have any recommended reading material in this area?
Yeah, there is a lot. But the issue right now with the recommendations that they are spread over different web pages. Within IT Asset Management Forum, we're trying to put together a document which is showing where you can get recommendation. But on very high level, the recommendation is always look on the embodied and the usage part. The more hardware you have, logically, the more embodied carbon footprint you will have. So if you are having 5 servers which are used on 20%, maybe it's more sensate to have it in 3 servers. Second is the usage. What is running on it and what is the energy consumption? Analyze your applications, analyze what is connected to the servers, to data center, and see what is making sense versus market. Again, to give an example, if you are having a server which is a middle-sized server which is consuming 2000 watts or 3000 watts, and you are having one application on it, let's analyze what is taking the more consumption there. Are you able to put more load on it or not? And this is also something what has to be taken from the architecture perspective. How I am designing to make sure that my solution is optionally loaded, not with 200 or 300% of margin, what happened very often in past.
How do you balance the decision between going to cloud and remaining on premise from a green IT perspective? When you didn't mention the ratio of embedded to usage emissions for cloud. I'm assuming it's probably roughly the same as it is for infrastructure, because of course the cloud has infrastructure.
Yeah,
the cloud
definitely.
Is infrastructure.
That is infrastructure. So it's again around 80-20, 80% do it to usage, 20% to do it to embodied. However, in case of cloud, the usage will be even higher. Why? Because the cloud provider, they are really looking on energy efficiency. It's their business. So they are having standardized infrastructure. They are having standardized servers. They are looking also, some of them at least, they are trying to optimize the life cycle of the servers in function of the energy consumption on the market. So let's say the energy efficiency of cloud data center, it's always better than energy efficiency of a on-prem data center. This is one point. Secondly, the load. As they are using dynamic scaling up and scaling down, they're able to optimize this also better on higher scale. There is a lot of material on the web which is showing you what you can save in terms of emission and on energy if you are moving to cloud. Depends to which cloud provider, you will get different numbers, like always, but it will give you an idea. What is true is what you need to take into account is that cloud, it's something which is giving you, I mean, it's saving you on some stage, and especially the embodied carbon footprint. However, you need to take in, especially in the explosion of IoT, you need to take into account that for every solution you have probably also edge infrastructure on site. This needs to be taken into account also, because the edge infrastructure is collecting the data, which which is normalized, compressed, and afterwards loaded up into cloud. So this needs to be taken into account.
And also the network emissions, because of course you're
definitely
transporting that, you're transporting bits a much greater distance than to on-prem as well.
Yeah, but again, make your investigation, because again there are a lot of numbers, and as I tried to show you on the 4 examples at the beginning, there is a lot of myths and legends, so try to be factual.
Yeah. So Ian asks, should we aim for net zero to be carbon neutral? Should green IT requirements feature in the non-functional requirements of every new software application or hardware device? If so, who would determine what the requirements should be? The government, the organization, developers? That's a big question.
It's a good question. What I recommend, I mean, on the organizational level, you can have a generic target for carbon emission of IT, saying, okay, how much I want to reduce, and then try, this is particularly the organization job, to break it down to see how I will achieve it. Okay. Now from the software side, if we look to be green by design, there should be no doubts. We should think about being zero carbon. I mean, to keep in mind the zero carbon principle. If we, the principle should be always what we can do to minimize the carbon footprint of our solution, of our software. Depends on the company, it's having different contexts, but again, you can always do something to reduce the processing demand from the software. In terms of modularity, using different modules, in terms of compatibility, what is called, reduce the number of transactions, and so on and so on. So it's a question again, you don't have gold solution. The question is how you analyze it to see what is the major contributor to the processing power demand and what you can do to reduce it.
So I think the final part of Ian's question is really interesting. Who should determine what the requirements should be? And he suggested the government, the organization, and the developers. And I think clearly we're seeing governments put in place legislation and requirements, and organizations implementing their own policies. But I think that's a really interesting point about developers. Can developers have an impact on the carbon footprint of the software they design?
Definitely. And I wouldn't count on government. Government can formalize, but I don't know if you heard about the broken window theory. It's come from the US. I think it was, I don't know, Chicago or Detroit. The theory comes from sociology, saying that if you have an area where you see houses with broken windows, after a while, the number of broken windows will increase and that streets will be more and more dirty. However, if this is only starting and you start to make this up, the phenomenon is not extending, you are stopping it. The idea is to be able to stop it on the early stage. And to stop this on the early stage, you need to have the community involved. That's why I was putting so much accent on the awareness. It's question of responsibility of every one of us, what we can do as a person, as an employee, as an organization, as a manager, as a CEO. Afterwards, on the country level, government definitely have to put some goals for the country, but they will formalize that what is the market standard and will follow the flow. It's very, very rarely that in politics you will set something in advance. I think the road is starting from ourselves.
Interesting. So oh, sorry, David says, no, Art says, sorry. I assume that IT for usage emissions are mainly energy consumption, but when we're thinking about embodied emissions, is there a significant impact from the chemistry of the materials used, or are the embodied emissions mainly the energy consumption during the manufacture and disposal processes?
You know, if we speak about chemistry and material used, there are different standards like ROHS for the toxic material and materials which should not be used, which are also important and, by the way, should be part of the directive for procurement to take this into account for procurement from the procurement perspective. Now, if you look at embodied carbon footprint, definitely the energy used to process material on chemical or mechanical way, it's part of the embodied carbon footprint. Yeah, I think that's.
Yeah, so I guess so what you're saying is it is mainly the energy. It's not like the manufacture of concrete or steel, for instance, where actually the chemical process is involved in the manufacture of the material, just by their nature release carbon.
It is taken into account. There are tables which are telling you what is the average carbon emission by producing 1 kilo of steel, for example, 1 ton. So it is taken into account. But what I was saying is it's not taking into account the toxicity of the materials and so on. But what energy need to be taken, yes. And also what is taken into account that it's not only CO2. I mean, CO2 is only one of the greenhouse gases. There are more of them. What is done is that those gases are converted on the CO2 equivalent.
Right. Interesting.
Okay.
Yeah. Okay, that's really interesting. So David says, would you have any advice on how to measure progress in this area? For instance, recommended decarbonisation level agreements, which can then be used to measure enterprise performance against the objective.
I can say just my opinion. I am not an expert in the areas on the official level. What I like to do if I'm setting KPIs is to know where I am, because to set a target without knowing where I am, it's setting a direction based on dreams, and dreams are very rarely becoming reality. So first, the step is to say where I am. Second, where I want to go, and then make a plan. What is realistic to go there? It's the famous plan, do, check, act. There's no rocket science behind. But if you know that right now, let's say my carbon footprint is 20,000 tons of CO2, and I want to reduce by 50% in 10 years. So the question is how I can reduce by 10% a year or 5% a year. You need to make a study to see what is feasible. If you set a target which is not feasible, this is the first contribution to make the program fail.
Right. Yeah. Jarek, it's 1:30 and we still have some more questions. Are you able to stay and answer the questions, or do you
Definitely,
need to go?
yes.
Okay, fantastic. Thank you. Appreciate that. So Darren says, do we need to consider the end-to-end journey for recycling, where developing countries such as Ghana are being polluted with piles of devices to be recycled, but there is no incentive for the market to create an industry for recycled parts?
This is a very good question, and it is again leading me to one of the topics I mentioned, is to the importance of make green principle embodied in our processes and policies. IT asset disposition, if you are just disposing the device without taking care of what is happening with the device afterwards, you are indirectly doing that what Darren is saying in his question. The way to prevent this, especially on the business side, is to make sure that the IT equipment which you are disposing are going to the recycling party, to the IT asset disposition companies, which are giving you at least some kind of confidence, trust that they are applying the sustainable rules. Definitely, again, ISO is one of them. You can look on partners which are certified in ISO 14000, but it is definitely not sufficient. It is not preventing the exporting of it and polluting, as Darren said, for example, Ghana. But you can check that several standards. You can look on the responsible recycling, R2, you can look at e-steward. Are those vendors certified? Do they have commitment to circular economy? Again, the last which any company want is that on some stage, there is somewhere a newspaper article saying that somebody found your server, your printer, your laptop from your company with a sticker from your company somewhere on the desert. Okay, so, but to prevent it, you need to think with the end in the mind, saying at the beginning already, if you are planning disposition, you need to make sure that your vendor is a trusted vendor for the disposition.
Thank you. How do you best, so we have a question from Andrew, how do you best balance the need to maximize green IT requirements with the need for redundancy and resilience in IT infrastructure and applications? These seem to have opposing requirements.
I'm not so sure they are so opposing. There is always optimization opportunity. On the other side, not everything has to be redundant and resilient. The critical parts have to be, but the non-critical, not necessary. The question is, are you applying the resiliency only to the critical parts or only to the parts which are business justified, or are you doing this by default?
So Andrew also said, using the concepts of the circular economy may help in reducing the impact of manufacture and disposal of IT assets, including through recycling. Any thoughts on this?
Definitely. There is, this is what I was also trying to say, that embodying circular economy principles in the processes, and especially in the IT asset disposition, it's helping a lot. I will maybe come back to the slides where I was showing the life cycle, and this is reflecting quite good this, the approach. So again, this part, the last part, is IT asset disposition. If you are just disposing it to the landfill, sooner or later you will find out that part of the landfill is landing somewhere in third-party countries, which nobody wants to know and hear about, but it is polluting our earth, and it's polluting also the population which is there, who is living there. Now, if you are making sure that if you're planning life cycle of your infra and you are making this correctly, you can definitely make this on a stage where the asset can still find a second life. You don't have to keep, if you can keep this until it is broken, but if you don't want it, at least make the retire at the time when you can give that to a school, you can give that to private people who can use it. Also internally in the company, you don't need there are different needs for devices. For example, for some R&D task, maybe you need to swap the devices earlier, but those devices are quite strong and they are maybe not sufficient anymore for the R&D engineers, but will be fully sufficient for modern office users. So why not to redeploy it? Do we look which devices are used by what? Do everybody need to have an engineering laptop? No. So do we have criteria which are allowing us to make it, to allocate the devices according to the business needs, not because of personal perception and personal needs? Because at the end, we are all human beings and we are very selfish by nature. We want always to have the most colorful and most touchy things. And it is up to the user will have always the newest and the showest, the best device. From the business perspective, do they really need it? And this is the role of IT asset management, to make sure that the assets are allocated, responsible, efficiently. And then again, choosing the recycling vendor, doesn't matter if you speak about IT asset disposition or simply e-waste, because here we speak also about electronic and so on. We need to make sure that they are trusted vendors and they are really try to reuse the element and to recycle, not just having this on the marketing leaflet. So do we have any controls to control it? And definitely it can help to reduce the embodied carbon footprint.
Yeah. So Andrew has also asked, has commented, we create a lot of excess and useless heat in running IT equipment and then have to spend lots more energy cooling the equipment down again. What percentage gains can be made by reducing the excess heat created and thus also the amount of cooling required? Should we be researching this much more to improve our energy usage efficiency?
Definitely. And the question probably is deserving a separate study. Now, having said it, on the market, you can see already symptoms that there are companies, there are institutions who are looking at it. There are data centers constructed which are looking how we can reuse the heat, for example, to heat also to make heating for a particular houses or for cities. So there are solutions. Now the question is, how do we force companies to go in this direction? You can force this item on the bad side by laws, which normally are coming too late and are not always perfect, or you can force that by demand. As a consumer, as a business, as a company, how I am selecting my vendors. And this is also why I was putting so much accent on the importance on embedding the green principle in the procurement. IT needs to make alliance with procurement and make sure that we are taking this to account, and through our selection, we are promoting green vendors.
So thanks so much, Jarek. I think that's it for the questions. So thank you very much. It's been a really, really interesting presentation. Really appreciate it. And as we were saying right at the beginning, you were saying that potentially you could do more of a deep dive into sustainable IT perhaps later on. So that would definitely be something we would love to discuss with you, because I think it's been really such a fascinating presentation tonight. So thank you very much again. And for everybody else who's still on the call, just a reminder that our next event is on the 20th of February in London. We hope to record that event, but it will be in person. So we hope to see you there. So thank you and have a good evening, everybody.